Hi guys, welcome to another episode of MrLopezClasses.com. This is the chapter 12 of our diesel engines class. Today we are going to talk about the diesel. We are going to talk about the petrodiesel, biodiesel, blended diesel, and vegetable oil. Yes, in this episode we are going to fabricate biodiesel. We are going to do the project to fabricate your own biodiesel. Yes, you can fabricate your own biodiesel and produce biodiesel for your company, for your cars, for your trucks. This is a special episode. Today I am going to explain a question that I receive every day in emails related with the reputation of the diesel engines. The diesel engines in some countries, the people say, no more diesel engines because the diesel engines increase the pollution in my country and blah 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 blah. Today I am going to demonstrate what is the reality about that situation. What happened with the diesel engines? Really the diesel engines are not good. It's necessary to eliminate the diesel engines of the roads, or probably the problem is in other place. It's not on the diesel engines. Today we are going to discover what happened with the diesel engines. But we are going to check quickly a small information related with the diesel. The diesel is coming. There are basically three types of diesel. Petrodiesel. This is coming from the petroleum, from crude oil. The petrodiesel. The other common diesel is the biodiesel. The biodiesel is coming from vegetable oil. Vegetable oil. And blended diesel. It's a mixture in between a petrodiesel and biodiesel. In what proportion? Today we are going to study what proportion is recommended. And pure vegetable oil. Pure vegetable oil is considered a fuel? No, it's not considered a fuel. Can be used, yes, in some specific particular situation. But those are the most common: petrodiesel, biodiesel, and blended diesel. Those are the most common fuels used in diesel engines. What is better? What produce less oxides, corrosive oxides? Right now we are going to discover what happened with those elements. Let me explain quickly what is the composition internally of the diesel. The diesel is less volatile than gasoline. It's a little heavier. Is made of heavy petroleum fractions. Ignite by compression in a cylinder with air full compressed. No compression of the fuel. When the air is full compressed at a specific pressure and temperature, if you inject the fuel ignites. You remember that? Okay. This is the ability of the diesel in comparison with the other fuels that ignite by a spark. Diesel, no. In the same way that the gasoline are labeled with octane rating. In gasoline, you remember the octane of the gasoline? In diesel, we are going to use other term. It's the cetane number. And it's opposite, like the octane. In our next class, in gasoline, I am going to explain what is the meaning of the octane. Octane 80, octane 90, octane 100. What is the meaning of that? But for today, I need that you be clear that Look, more octane, slow burning. Higher octane, burn slow. This is contradictory. The people normally think that if you ask to the people, what do you think about how fast is produced the explosion in a gasoline with a low octane, 87, or a gasoline with a 97? Which gasoline explodes faster? The gasoline with a low octane explodes faster, or the gasoline with high octane? And normally the people respond, the gasoline with high octane explodes easily. No, it's opposite. Yes, we are going to study that situation in our next class of gasoline. Today, in diesel, it's completely opposite. It's better a diesel fuel with higher cetane number. Higher cetane number. What is the maximum cetane number? Is around 50. 45, 50 is the maximum cetane number. Yes, this is the number that we are going, the reference number that we are going to use when we talk about diesel. What is the meaning of the cetane number? The cetane number, or Cn, is an indicator of the combustion speed of the fuel. It is an inverse to the octane. Yeah. In a particular diesel engine, higher cetane will have short ignition delays period than lower cetane fuel. Cetane numbers are only used for the relative light distillated diesel oils. For heavy residual fuel oils, two other scales are used, CCAI and CII. But we are going to be concentrated only in the cetane number, that this is the number that we are going to use like a reference. Cetane is often used as the shorthand cetane number, and this is the measure of a combustibility of a diesel fuel. Cetane ignites very easily under compressed air. Compressed air. Compressed air. That's the meaning of cetane. Okay, my friends. Cetane number. Look at this. A cetane rating of at least 40 is recommended for temperatures above 32 degrees Fahrenheit. 33 degrees Fahrenheit. A cetane rating of at least 45 is recommended for temperatures below 32. Yeah? For temperatures over 32, a cetane of minimum 40 is recommended. A cetane of minimum 45 is recommended for temperatures below 32 degrees. This is important depending where should be located your diesel engine. At north, close to the pole, low temperature. In that case you need a high cetane. 45 is okay, 45, 50. And what about the temperature? The temperature is superior to 32 degrees Fahrenheit. Minimum 40 cetane is recommended. Okay, this is related with the cetane number. Okay, the viscosity, my friends. In comparison with gasoline, the diesel, the fuel, is high viscosity. It's oily. Yeah, higher viscosity. And of course, that excessive viscosity affects the nozzle on the injectors, and of course affect the atomization, the pattern, when the injector opens. The injector systems work properly at the properly viscosity recommended for that engine. Yes, my friend. For that reason, I'm going to explain later, not all the diesel engines can be used with a vegetable oil, because a vegetable oil is too heavy, high viscosity, and probably clogged the injectors. you can use vegetable oil in a special situation, I'm going to explain later, and with a special fuel injection system, mechanical fuel injection system, and but never use vegetable oil in electronic fuel injection system and modern diesel engines. Be careful with that. I'm going to explain what is the meaning of that. All right, for example, fuels that meet the requirements of 1D or 2D diesel fuels are excellent for Cummins and Caterpillar. But this is a particular, specific situation for those manufacturers. Once again, be careful with the water and the sediments. That's the enemy of the typical diesel fuels. Affect the life of the filters and injectors, of course. The amount of water and solid particles in the fuel is generally classified as water or sediments. More water vapor condensed in partially filled tanks is basically because the dramatic change in temperatures. The dramatic change in temperature produce evaporation, and the vapor on top of the tank is condensated and in water, and that amount of water drops into the fuel. That's the situation. But the enemy of the most important that you need to keep in mind is the enemy of the fuel is the water, of course, the contaminants, and the air. Yeah, remember what happened if a small bubble of air entered in the fuel injection pump. That bubble is expanded in diameter, in volume, and blocked the system. And the water eroded everything, destroyed the nozzles of the injectors, and destroyed the engine. Be careful with the water, especially if the water is salt water. No. For that reason, the service on the Roycore Parkers, on the primary filters, you remember the episode related with the fuel filters and priming pumps, I recommend that video in order to check the procedure to clean primary and secondary filters. Okay, my friends, yes, that's the procedure. In the previous episode, I explained the procedure step by step in order to do the service on the water separator filter. You found the information also in our diesel engines book, step by step. Okay, my friends. Okay, once again, exactly the same like gasoline. Right now we are going to check what is the formula, what is the internal structure of the diesel. But basically the diesel is carbon and hydrogen. That's it. Carbon and hydrogen. But if the diesel doesn't have impurities, contaminants, no problem. But if you have contaminants, impurities like sulfur, like nitrogen, like phosphorus, and metals dispersed, those contaminants separate the structure and create free carbons. Those free carbons are accumulated like carbon deposits. Those carbon deposits are too hard and avoid that the valves close properly, for example, because normally those carbon deposits are accumulated on the intake valves. Yeah, and when the temperature of those deposits of carbon decrease, those crystals avoid that the valve close properly. And of course you have problems. You remember what happened if the valves don't close properly? What happened when the piston is going up during the compression? You can compress the air properly? No, because a couple of valves stay open. When you go up with the piston, the air is not compressed, and of course when the fuel enters in the combustion chamber, the fuel ignites? No, and the fuel goes out through the exhaust pipe and you have fuel outside of the pump. That's the consequence. All right? For that reason, the amount of carbon deposit is critical in the performance of a diesel engine. Yeah, the tendency of a diesel fuel to form carbon deposit in an engine can be estimated by various tests. Yeah, I am going to explain later. Other sample that is recommended take is the sample of fuel in order to verify what type of contaminants I have in my fuel tank. Okay, let me I refresh quickly a couple of terms that we need to understand the performance of the fuel. The boiling point, you remember, that's the temperature at which the liquid changes to vapor. That's the point of a change of state from liquid to vapor. What is the meaning of viscosity? Viscosity is the degree to which a fluid resists the flow under a standard force. Basically, viscosity is the measure of drag, of resistance to the flow. The more viscosity a liquid, the more resistant is to the flow. Generally, viscosity decreases as the temperature increases. Of course. Volatility. Volatility is the measure how quick a substance forms a vapor at ordinary pressure and temperature. Yeah, that's the volatility. And sulfur, that's the key word in this episode. Sulfur is a compound that corrodes the metals in the fuel, and the control of the amount of sulfur determine the quality of the fuel. Yeah, my friend. This is today, the start of this video is sulfur. And we are going to talk about sulfur in different forms, in different ways. All right, my friend, ready to start with this important information about the production of diesel. Let me explain something about that. Like I explained in the first slide, diesel is coming from petroleum, or diesel is produced from vegetable oil. No, the basic types of diesel. The diesel coming from petroleum is coming after a process of distillation. In the process of distillation, you have the crude oil and start the process of distillation. What is the meaning of distillation? It's a process that remove contaminants and remove excessive amount of dispersants. Yeah, it's a process that in each step remove contaminants. Okay, in that process, at the 5th or 6th step, you have diesel. Yeah, you have diesel easily. You need to remove a couple of carbon deposits, sulfur deposits, phosphorus deposits, and other aromatic substance, and you found it sulfur. But there are other additional steps in order to produce diesel with high quality. The following steps depend on the amount of sulfur that you remove. In other words, for example, in the 6th step you have diesel, but in between the 6th step and the 12th steps you have diesel with more quality. Or the diesel in the 12th step is a high quality diesel. Right now I am going to explain what is the meaning of that. Depends on the amount of sulfur suspended in the fuel. How can you measure the amount of sulfur? We are going to use the terminology parts per million, per volume. Parts per million. What is the meaning of that? I am going to check in a sample of fuel. For example, I have this bottle with diesel. In this volume, if I have some parts per million of sulfur, I can consider that fuel good quality or low quality. Right now, I am going to check a picture with the composition in parts per million of the diesel in different countries around the world. And we are going to try to understand why the performance of some diesel engines is better in some countries and is not good in other countries. Is because the amount of parts per million. For example, the amount of parts per million in the United States is around 15 parts per million. It's a little amount of sulfur, but that amount is considered a good number. In other countries, they have 10 parts per million. And in other countries, I have 5,000 parts per million. 10,000 parts per million. For that reason, you found that in those countries, a lot of trucks producing black smoke, like the truck that you have on the picture right now. But it's the same truck. Yes, my friend. It's the same truck. It's the same truck that, for example, the people have in the United States, Ford, International, Chrysler, Chevy, or Toyota, or Honda. Those are the same trucks, but in those countries, the same truck with the same engine produce that amount of black smoke. That truck in other country with good of diesel with low level of sulfur, no smoke. Yes, my friends. In other words, the diesel engines, the performance of the diesel engines depend on the quality of the fuel. The smoke, the contamination, is not because the diesel engine. It's because the quality of the fuel in your country. In my country, I want to eliminate all the bus, trucks, pickup trucks, diesel, because produce a lot of smoke. All of the trucks, all of the transportation equipment and agricultural equipment produce, yes, a lot. But those equipments, those trucks, those tractors are the same equipments used in other countries like Europe or the United States. And in those countries, the same trucks, they don't produce smoke, nothing. You put those trucks in your country, and in your country produce black smoke. Is the truck? Is the engine? Probably no. Probably is the quality of the fuel. Of course, there are other factors related with the service on the air filter, service on the calibration of the fuel injection pumps and injectors, but this is minimum in comparison with the quality of the fuel. Yes, my friend. Let me show to you how much is the amount of sulfur in parts per million in different countries. And we are going to try to understand this difficult equation. This is the slide. In this slide, we are going to analyze in different countries around the world the amount of sulfur dispersed on the diesel. We are going to start with the United States. What happened in the United States? We have 15 parts per million. Okay, it's a good number. What happened in Central America? It's in between 10 and 8,000 parts per million. That's not good. There are a lot of the same in the Caribbean. There are a lot of islands in the Caribbean with bad fuel. Yes, my friends. For that reason, when you visit with your boat the Caribbean, you need to be careful with the fuel. You need to be careful with the fuel. This is, look at the composition. In between 10 and 8,000 parts per million. In comparison with the United States and Alaska, is 15 parts per million. That's not good. Let me check what happened in South America. In South America, in general, is in between 50 and 1,800 parts per million. That's not good. Let me check Venezuela. Venezuela is more than 500 parts per million. It's not good. Colombia is around 50 parts per million. Colombia is working a lot with the biodiesel, blended diesels. Ecuador is the worst in comparison with the rest of the countries in South America. It's in between 3,000 and 7 parts per million. It's a lot. It's a lot. That's not good. What about Uruguay? Uruguay is 50 parts per million. It's good. Argentina. Congratulations, Argentina. Great job. 10 parts per million. Is, in my opinion, the best of America. From Alaska to Argentina, Argentina is the best. 10 parts per million. Argentina is at the level of Europe in the quality of the diesel. Excellent. What about Brazil? Brazil is a big country, and Brazil have different areas, but Brazil is working a lot. is in between 10 and 1300% of parts per million. 1300 parts per million, sorry. But Brazil is working a lot. Brazil is other good example because Brazil is working in biodiesel and is working in a blended petroleum diesel with biodiesel. But the scenario of South America and Central America is not good. Now you understand why the pollution in the majority of those countries is because the quality of the diesel. Let me check other countries. Let me check Europe. What happened in Europe is in between 10 and 50. It's good. The majority of the countries have 10. Excellent. It's good. Okay, let me check, for example, in Russia. Russia is not good. It's in between 350 to 500 parts per million. This is a worse scenario. That's not good. Let me check what happened in Asia. Asia is perfect. 10 parts per million. China, Japan, Philippines, 10 parts per million. Good, excellent. Congratulations. Let me check in Africa. Africa is good. In between 10 and 50. And let me check Australia. Australia is not good. It's in between 50 and 150. This is the situation in the world in relation to the content of sulfur, the key word when you check the quality of the diesel. Okay, my friends, right now you understand why, depending on the composition of the amount of sulfur in the fuel, the result is different. Yeah. And this is only one example. It's not only sulfur, the element that produces excessive contamination. Nitrogen. Nitrogen is another element that produces excessive amount of contamination. Another one is carbon. Another one is phosphorus. And other suspended metals. What happened with those elements in particular? With sulfur, with carbon, with nitrogen, with phosphorus. Those elements, if those elements are free after the explosion, those elements in combination with the oxygen produce oxides. Nitrous oxides, sulfur oxides, phosphorus oxides, carbon oxides, and those oxides mixed with water produce sulfuric acid, carbonic acid, nitric acid, phosphoric acid. And those acids in the environment produce acid rain. And those acids in a marine engine enter in the ocean. Acids. Now you understand what is the situation? It's not only with sulfur. Sulfur is used like the key word in order to measure the quality of the diesel in different countries. In the previous slide, it's wonderful because we analyze what happened in Europe. In other words, Europe and Asia are in good conditions. The United States, 15 parts per million is okay, but could be better. 10 parts per million is a good number. But there are countries with 7,000 parts per million, 5,000 parts per million in the Caribbean, in Ecuador, in some countries in Latin America. That's not good, my friends. Yes, my friends, you need fight in your country with the government in relation with the production of diesel. No to eliminate the diesel engines, my friends. The diesel engines are, in comparison with the rest of internal combustion engines, the most efficient engines. And I am going to explain in other episodes why try to eliminate the diesel engines from the market is impossible. Today is impossible. I don't know what happened in 20 years. But today, any other engine any other electric motor, AC or DC, produce the torque that a diesel engine produces. I am talking about the torque. How much torque produce? Yes, for that reason, in agricultural, in industrial situations, in transportation situations, the diesel engine is unbeatable in comparison with the rest of the engine. But this is the topic for other episode. Okay, my friends? Alright, I want to continue this explanation in order to understand what happened with the diesel and what happened with the biodiesel. Okay, my friends, look at this, the density of the diesel and the density of the gasoline. The density of the diesel is around 6.9 pounds per gallon, and the density of the gasoline is 6.2 pounds per gallon. Yes, in general terms, diesel is heavy in comparison with gasoline. 6.9 pounds per gallon in diesel in comparison with 6.2 pounds per gallon in gasoline. Yeah, it's heavy. It's heavy, the viscosity is heavy, the lubricity in diesel is heavy in comparison with the gasoline. Look at the formula. This is the formula, the chemical composition of diesel. It's basically 12 atoms of carbon per 23 atoms of hydrogen. It's carbon and hydrogen, that's it. Carbon and hydrogen, that's it. Incredible, no? Two elements, depending on the combination, produce diesel. Yeah, 12 atoms of carbon together with the 23 atoms of hydrogen create a molecule of diesel. This is the typical molecule. Of course, that molecule is affected when you have other contaminants, phosphorus, sulfur, and nitrogen, and the molecule is affected and the efficiency of the molecule decrease. What is the meaning of the efficiency? The cetane number decrease and how fast is the explosion is reduced and the performance is reduced. Simple. More contaminants, less ability to explode. That's it. Simple. Petroleum diesel is composed of 75% of saturated hydrocarbons and 25% of aromatic hydrocarbons. I'm going to explain later what is the meaning of that situation. Look, basically, the chemical formula for diesel is hydrogen and carbon, except small amounts of impurities or additives, but it's basically carbon and hydrogen. Carbon and hydrogen. This is wonderful. How those molecules are connected with molecules of oxygen. Yeah, this is the composition of diesel. This is another important slide. Diesel is generally simpler to refine from the petroleum than gasoline. I explained. In the first step, you have diesel, and you need to go down, 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 down in the process of refination in order to get gasoline. And contains hydrocarbons having a boiling point in the range of in between 360 to 680 degrees Fahrenheit. That's the boiling point. This is a magic number. You remember what happened if that temperature is over that limit, pass to vapor and produce vapor lock. The enemy of the combustion chamber in a diesel engine is the vapor lock. Okay, my friends. In other words, the quality of the diesel in the world is measured according with the amount of sulfur in the fluid. Yes, for that reason, in the United States, after 1996, the diesel is considered ultra low sulfur diesel because the diesel in the United States in general contain around 15 parts per million, and this is considered ultra low sulfur diesel, the diesel with around 15 parts per million, and this is the amount of particles of sulfur dispersed per volume in the United States and Alaska. 15 parts per million. This is considered ultra low sulfur diesel. Yeah, ultra low sulfur diesel, 15 parts per million. What is the difference between highway and off-road fuel? Nothing. Nothing. Only the color and the taxes. That's it. No difference. One is red and the other one no, but it's basically on taxes. The quality of the fuel is the same. No difference. Only in the price. Off-road diesel is colored usually red and has no highway taxes in the price. That's the difference. No more difference. Alright? But be careful. Use the fuel recommended for your truck and use the fuel recommended for your boat. The red color is important in the marine fuel for one important reason. If you have leaks of fuel inside of the engine room, it's easy identify, because the color, the red color, where is the leak. If you use on-road diesel for trucks in your boat, no problem. The engine runs exactly the same. But if you have a leak in the bilge, you don't know if that fluid is hydraulic fluid, because the color is pretty similar, or if that fluid is diesel, or if that fluid is other coolant. It's difficult check the difference. For that reason, in marine application, the red color is excellent to identify if you have leaks. Another important thing that I repeat is be familiarized with the odors. The odor of the diesel, the odor of the hydraulic oil, the odor of the motor oil. Those odors produce different vapors, and you can identify easily where is your leak. The odor of the coolant is completely different, like the odor of the automatic transmission fluid and the odor of the electrolyte of the batteries, and you need to be familiarized with those odors.